Okay, now I'm going to do a video walkthrough of the other Desmos activity, practice with velocity graphs, uniform in stages. So here I've got a graph that says my initial position is 4 meters. I've got a velocity graph right there. I'm going to sketch the position graph that matches it. All right, initial position is 4 meters. So let me start by, actually, I'm going to make myself a new one because I think that's maybe the same one I did in class. So the initial position is -4 meters. So I want to make a point right here at -4 is my initial position. And then I'm going to look at this graph and notice that it is traveling at 4 meters per second for 1 second. That means it's going to move forward by 4 meters in the positive direction from that position. So if it started at -4, it's going to end up at 0 1 second later. And then we're going to repeat. In the next second, it goes forward by another 4 meters. This is that area thing. 4 meters per second times 1 second. Goes forward by 4 meters. It's like another point right there. Oh, I want to make that green. Next one green. And then 1 second after that, it travels another 4 meters forward. So at the end of 3 seconds, it is now at position 8. 4 plus 4 is 8. And then it travels another 4 meters forward. So at the end of 4 seconds, it's moved from 8 to 12. So 8 to 12 right there. And I can connect all those dots. Make that black. So it starts at -4 and goes up to 12. And then the velocity suddenly changes from +4 down to -5, which means it's going to start going backwards by 5 meters each second. So let me start filling in that. So we're going to go backwards by 5, sorry. Let's fill in that area. And that corresponds to going backwards by 5. It was at 12, so it's going to end up at 7. 5, 6, 7. I wanted that to be red. So at 7. And then it's going to go backwards again by another 5 meters. So I need to go backwards from 7 to 2, right there. And then it's done with going at that speed for a while. So I'm going to connect up those dots. So it goes from 12 down to 2. And then, hard to see, but the velocity is 0 for the next 2 seconds. So for the next 2 seconds after that, it's going to stay right where it was. So it's going to stay at 2 and then 2 again. And then I'll connect those up. So it stays at 2 meters for those last 2 seconds. That's my graph. That matches up. You've got a constant slope of 4, and you've got a constant slope of -5, and you've got a constant slope of 0. And then I can do the questions. What's the total distance traveled in meters? Okay, well, it went forward by 4 seconds times 4 meters is 16 meters. And it went backwards by 10. 5 meters per second times 2 seconds is 10. So 16 and 10 is 26 meters. So on a total distance of 26 meters. What's the total displacement in meters? So that's the difference between where it started and where it ended. Or rather, where it ended minus where it started. So it ends at 2 and it started at -4 as a displacement of +6. 6. What's the final position of the object? You get that right off the graph. It's at 2. The final position is 2 meters. And what's the highest speed of the object during the trip? So that's when is it going the fastest? Well, it's going 4 meters per second for the first part, -5 for the second part. The highest speed is 5. And submit and submit. And then I can check my work on the next page. Show me the answers. 6 and 6, 26 and 26, 2 and 2, 5 and 5. Graph matches mine. All right, I did it. Okay, so key parts of that process are finding the area underneath the velocity graph and using that to map out the changes in the position, and then using those two graphs to answer the questions about the total distance and the displacement, and remembering what those are and how they're related to each other. That's it. Thank you.